In this video, we'll solve the logarithmic equation log base 2 of x equals 5 minus log base 2 of the quantity x minus 31. We first want to collect all of the log expressions on one side of this equation. We can do that by adding the log base 2 of x minus 31 to each side. This gives us log base 2 of x plus log base 2 of x minus 31 is equal to 5. We can combine the two log expressions by applying the product rule of logarithms. The sum of two logs is the same thing as the log of the product of their arguments. The left side is written then as log base 2 of x times x minus 31 is equal to 5. Now we can convert this equation to its equivalent exponential form. Recall that log base b of x equals y is equivalent to b to the y equals x. This equation is then equivalent to 2 to the 5 is equal to x times x minus 31. Simplifying each side, we get 32, right, 2 to the 5th is 32, equals x squared minus 31x. This is a quadratic equation we want to solve by setting one side to 0 by subtracting 32 from each side. This will give us 0 equals x squared minus 31x minus 32. This equation factors as x minus 32 times x plus 1 is equal to 0. Setting each factor to 0, we get x minus 32 is equal to 0, or x plus 1 is equal to 0, which is x equals 32, or negative 1. But again, we cannot stop there. We have to make sure that the numbers that are our proposed solutions do not make the argument of the log negative or 0. We need to check by plugging 32 in place of x, and when we plug 32 in on the left, the log expression is defined. 32 minus 31 is 1, so that's fine. If we plug in negative 1 in place of x, note that we would get log base 2 of negative 1, but that's an undefined expression, so we have to exclude our solution of negative 1. Therefore, our only solution is 32, so the solution set is a set containing 32.